finally see. Start. On May 30, a startup named Agnikul Cosmos successfully conducted the first test flight of its rocket Agniban in a mission called Suborbital Tech Demonstrator. The flight was Agnikul's fifth attempt after the first four were called off owing to suboptimal launch conditions. Agniban is a two-stage 14-ton launch vehicle designed to lift small satellites to low Earth orbits. Both stages are powered by bespoke semi-cyclone energies. The test flight flew a minimal version of the rocket with one engine or stage. Notably, many of the vehicle's components, including the engines, are 3D printed, and Agnikul has said it will be able to build one rocket a month. With the test flight, Agnikul took Agniban on its first steps towards being a full-fledged launch vehicle, which will expand India's commercial launch services offering in keeping with the expanding market for small satellites and the services they can provide. The roster is currently dominated by the Polar Satellite Launch Vehicle (PSLV) and will soon be joined by the Small Satellite Launch Vehicle. Both of the Indian Space Research Organization ISRO. One blip Agnikul will have to address is the subpar communication of the parameters of the test flight. This is one area in which ISRO has not distinguished itself, and it is important for new space startups to steer clear of the same mud. This said, the flights of Agniban and Skyroot's Vikram in 2022 herald two prospects more valuable than commercial fortune. ISRO and or scientists trained there have shared technical know-how and provided physical systems for many private missions, which these startups are now testing, cutting short the time and expenses required. Likewise, these startups are poised now to light the way for ISRO and others, potentially accelerating innovation in the sector. For example, ISRO has been testing a semi-cryogenic engine or of its own that could draw from lessons learned at Agnikul. The government must ensure that the corresponding bureaucratic and legal frameworks encourage the free flow of knowledge. Second, in April, ISRO said it had developed engine nozzles made of a carbon cosmetic to replace the cadmium alloy nozzle on the PSLV's fourth stage. The switch increased PSLV's payload capacity by 15 kg, a significant amount for an already technologically mature launch vehicle, made possible by education and research opportunities that allowed know-how accrued in some sectors to disperse in others. This privilege is currently most pronounced in India's spacefaring enterprise. As more innovation enters the fray, it is hoped that the resulting resolution and insights will benefit everything from aerospace to geology stuff.